So the video today is about circle trigonometry. So using circles to find the trig functions instead of just setting up the triangle like we did on the last one. Again, I will highlight the optional things in red, or the optional sides. So the unit circle, you've probably seen it before. It's a circle with a radius of 1, so it's 1 unit. Any angle on the unit circle starts from the x-axis, so starts here and then goes some other angle. So you're going counterclockwise, so always here, and then some angle here, and then some angle. If it goes the opposite direction, it's then going to be a negative angle. So your theta can be any size. So this one here in black is 450 degrees. So it went all the way around the circle once for 360 and then an extra 90 to hit up here. You can also be less than 0 and go negative. That changes the direction. So you're going clockwise here instead of counterclockwise. So think to yourself, what do all these angles have in common? Okay, so what they all end in the same spot. You always get this as your end angle, your terminal point. Angles like that are called coterminal angles. They're angles that share a terminal side. There are 2 ways this can happen. First, one of them is less than 0, so it's negative, so it went the opposite direction. Or one is bigger than 360, so it went all the way around the circle once and then kept going to some other spot. So, how to find coterminal angles? Here, if you're in degrees, you just want to add or subtract 360. So take negative 90 and add or subtract 360 to get your coterminal angles. So you could get 270, you could get negative 450, you can get 630, etc. And you could keep going on forever and ever. There's an infinite number of coterminal angles. If you are doing it in radians, you want to add on, so add or subtract 2 pi. Make sure you get a common denominator first. So if we have 9 pi over 4 and we want to get a coterminal angle, I want to add 8 pi over 4 to this. So I'm taking 2 pi, multiplying it by 4 because that's the denominator to get 8 pi on the top. And your answer would be 17 pi over 4. And you can do the same idea and subtract your 8 pi over 4 to get pi over 4 as another coterminal angle. And again, you can just keep doing this, keep subtracting and adding 2 pi to get more coterminal angles. So sine, cosine, and tangent in terms of this. So if we have our triangle here, we have this radius, right? So it would be our hypotenuse. You have your angle right here, so this is your opposite side, this is your adjacent side. We can then write out what these are. This would also be, if I switch colors, this is going to be your x and your y. So if sine is opposite over hypotenuse, we're going to get y over r. Cosine will be x over r, and tangent will be y over x. So you then can just keep using these to figure out what your sine, cosine, and tangent are without having to draw a separate triangle. So sine is always going to be y over r, cosine is always x over r, tangent is always y over x. So here it is all in a nice, succinct square. So you can use this to write down if you want. So, an example. Here, we know we have the point -5, -3. Let me zoom in a bit. If I connect this here, we can make a nice 90-degree triangle. Our x is a -5, our y is -3, and then we need to figure out what the hypotenuse is to do the Pythagorean theorem here. So you can do your a squared or -3 squared plus -5 squared equals c squared. You should get 34 equals c squared, or root 34 for c. And now you can use this triangle to find your sine, cosine, tangent, etc. So sine is opposite over hypotenuse. I'll write the SOHCAHTOA down here again so you have it. So So opposite over hypotenuse, switch colors, here's our angle, here's your opposite, adjacent, and hypotenuse, or you can do y over r, so -3 over root 34, -5 over root 34 for your cosine. Tangent is going to be -3 over -5, so it ends up being +3 over 5 when you cancel out the negatives. And then for the next one, you just take the reciprocal. So get negative root 34 over 3 for cosecant, negative root 34 over 5 for secant, and 5 over 3 for cotangent. All right, so then what happens if you can't actually draw a triangle here? So here we can't draw a triangle, we're straight down, but we do know our x and y. And then you can find your r by doing the Pythagorean theorem. So if x is a, we want 0 squared plus b squared. So you'd get 16, r is going to equal 4. And then you can use these to fill out your trig ratios. So sine is going to be y over r, so -4 over 4, or -1. Cosine is 0 over 4, or 0. Tangent is going to be -4 over 0, which you can't do, so you get undefined. Cosecant is the reciprocal, so you would get 4 over -4, which is -1. Here we get 4 over 0, or undefined, and then 0 over -4, or 0. All right, this next chunk is optional, so you can start ignoring me if you like, down to the homework, I believe. Yep. So here, sine, cosine, and tangent are positive in certain quadrants and negative in certain quadrants. And it relates to like your quadrants here. We have a positive x and a positive y. So here, x and y are both positive, which then means tangent is also going to be positive. So over here, we have negative x and positive y. So sine is going to be positive in your second quadrant because it's positive y, and the other two are going to be negative. Here we have negative x, negative y for your third quadrant. So tangent is going to be the only positive one. So negative y divided by negative x makes a positive number. Quadrant 4, positive x, negative y. So here cosine is going to be positive because it corresponds to the x values. Here it is all in a nice chunk. If you want to figure out how to remember this, you can do all students take calculus. So all for the first, S, second, T, and C. So all students take calculus. So the last example here, this is telling us we have a negative sine and we have a negative tangent. So if we try and figure out what quadrant this is in, we have all students take calculus, right? So sine has to be negative, which means we can't be either of these two quadrants. And then tangent also has to be negative, so we can't be this quadrant. So we have to have something down here. So draw a triangle. Here with sine, we know this is opposite over hypotenuse. So the hypotenuse has to be 5 because that's always a positive number. And then -3 here, which makes sense because we're going straight down, it has to be negative. And then you can solve backwards to figure out what this is. Since these are nice numbers, it's a Pythagorean triple and you're going to get 4, but you could plug this into the Pythagorean theorem and figure it out if you don't remember that. So then cosine is x over r. So x is 4, r is 5, you get 4/5. And then cotangent is 1 over tangent. So if tangent is y over x, cotangent is going to be x over y. So you get 4 or -3 or -4. So that's it for the notes. Ignore this assignment.